So today we'll study remaining part of Bitcoin and blockchain. Okay, all right. Now, note that we are not going to go into great details, but we will focus only on the basic concepts because we have just about 2 hours overall. So we have 1 hour left out, right? So I will be a bit fast. Feel free to ask me questions, and I have included a lot of diagrams, right? Because that will enhance your understanding. These references are the same. Okay, and these are topic we'll cover today. Okay, we'll go one by one. First, we'll start with basic principles, and then we'll look at the process, right? Okay. Of course, what we are doing is decentralization. There's nothing called central server here or any agency, Bitcoin agency or blockchain agency that will do the task. Okay, it's all decentralized, it's peer-to-peer. So essentially, what does it mean? Government has absolutely no clue, nor police has any clue what exactly is happening. And that is the all aim, right? That no governing party or government or any other central party should come into the play. When Alice is sending Bitcoin to Bob, and when Bob is running some shop, government should come to know about it, and that causes problem. Then all kinds of problems that some of this transaction may be illegal, there's also concept of tax and all that, and then this system, then government has to work with Bitcoin etc to make sure that taxes are paid and so on and so forth, right? So there is no regulator, that's the biggest risk. Okay, and if you lose your Bitcoin, somehow there's no way you can recover it back. Okay, and there have been a lot of cases where systems have been hacked and Bitcoins have been stolen. Okay, there is also another risk that if identity of a user is by public key. Okay, is actually public key of machine, and that public key you are generating by yourself and doing a transaction through that. And if you lose the corresponding private key, then you cannot recover your money at all. So there are people who have lost it because somewhere or other you will store that key, right? Private and public key, and let's assume that that machine gets hacked and somebody uses your private key to do transaction. No, there's no governing party who can help you out with that, right? Okay. Okay, so there's a concept, of course, a wallet where the transaction details are there, and there's there with each user. Okay, second thing is that nobody can reverse a transaction. Okay, whole blockchain and Bitcoin work in the concept that once transaction is done, it cannot be reversed. It means that suppose you have paid by mistake $100 or equivalent to $100 Bitcoin in Bitcoin, and then you want to undo it, you can't do it. You're not allowed to undo such transaction. So what can be done? Suppose you have made a purchase and you're not happy with it, then the merchant cannot undo the transaction. That will remain in the blockchain, that transaction that you between Alice and Bob. But what Bob can do is that Bob can do another transaction with you and maybe give the money back or Bitcoin back, right? Okay, now this has a lot of risk. Okay, someone please mute your mic. Okay, now with that, let's start with Bitcoin design principles. First thing is that identity. For any transaction between two entities, I mean, when we say Alice and Bob, these are the entities, right, of two individuals, like your name and your IP address and all that is your identity, your passport, etc. This identity. Okay, now we are not talking about individuals here. The transaction Bitcoin is always used between machines, right? Okay, now you can have multiple you can have, as you know, that in your machine you can have multiple VMs. Okay, so basically is identity of a machine, and that too identity you are generating it by yourself. Okay, so there is no central entity because everything is peer to peer. There is no Bitcoin regulating agency, because it will then work like a bank or government, right? That will issue your user ID and password. Nothing of that sort. So each entity has to generate by itself or herself or himself public key and private key. Okay, and now when you're doing a transaction with somebody, then you have to use both. You have to use SK, when you're sending a Bitcoin to somebody, then this transaction is to be signed by your signature, which is private key. And when you want to receive something, people know only about your private key, your public key, right? So they will send you Bitcoin with respect to with the destination as your public key. Okay, so if somebody sends you money, and then in order to unlock that, you will have to use a private key. Okay, all right. Okay, all right. So private key is chosen at random. Okay, and public key is generated for you. Note that this process, right? First you generate private key, and then from that public key is generated, because we have seen that there is a relationship with public key and private key. These can't be totally randomly chosen independently of each other, right? Otherwise you can't do decryption. Okay, all right. So public key is for receiving and private key is for redeeming or sending, and of course for redeeming and also for doing this sending money. So you'll have to do digital signature on it. All right. So digital signatures are done when you spend fund, or when Alice sends a Bitcoin to Bob, then Alice will sign this transaction. Any question? Okay, so public key, yeah.
Yes, sir, my
Public key,
private key and my
yeah,
public
yeah.
key is with the company with which I have made a wallet, right?
No. See, all these algorithms are available to you, but public key is randomly generated, private key is randomly generated, right? Okay, and from that you derive public key, and then you publish public key to everyone that this is my public key, and then you can do transaction on that. So people can send you something, some money or whatever, Bitcoin on that. These are all independently. See, wallet maybe it may be application, right? But it will use some algo to independently generate for you, and these wallets are not controlled by anybody. These are just application to you, right, with you, and these will generate using some algorithm, or you can do it without wallet also, generate some public key and private key for yourself. Okay. Oh, of course, there is a set of users will define how to do it. There are a lot of companies around it, and they'll say that you use this software to generate. Okay. So everyone has to generate, who want to participate in this, their own key pairs. Okay. Without that, you cannot participate. Okay. All right. So public key, and for example, this gentleman will generate secret key and public key, or private key or public key, and keeps secret key secret, private key secret, and announce public key, and so on and so forth, right? So once other person knows the public key, then can do the transaction, because suppose Alice wants to send something to Bob, Bob's public key must be known to Alice, and then Alice will create a transaction and then sign that transaction and sign with her private key, which Bob can use public key to verify the transaction is valid or not. Okay, we'll come to that part later. Public key in Bitcoins are called addresses. Okay, because based on public key you are doing all the transactions. Now it is recommended not to reuse the address. You generate your public key, use it for transaction. one transaction, maybe sometimes more than one. Okay, but it is not recommended to use it for long. So it means that almost so for every transaction you have to generate public key and private key. Okay, now this will also help you in being little anonymity. I mean having anonymous, right? Because if you keep the public key same for very long, then people will know about you. And it happens because an organization, for example, there is a store through which you are buying using Bitcoin, and public that store cannot change the public key very often, right? So in some sense it's not totally confidential. Okay, but anyway, private key remains private, public key is fine, but your address is through your public key. So ideally every new transaction you should use new address. Okay, all right. Now when you generate public key and private key, no personal information is required. Now when you go to bank and ask them to create account for you, they will ask hundreds of things, right? Okay, now here, and in fact you should try to do that, generate, I mean you should just put some small amount of money and then participate in whole Bitcoin thing, and you'll learn to know how to create your address, right, which is public key and private key. And then there's no personal information is required, as we said, no limit on how many accounts you can open, because it's a machine, it could be any machine, it could be number of VMs, right? You can so it doesn't matter, you can create any number of accounts on your machine. Okay, no restriction on the key that you have that has been taken. You can generate your key independently of all other millions of users. So does this mean that somebody else can have private key same as me? Yes, there is a very little probability that we discussed in last class, right? Can I have multiple keys? Yes, if you have multiple accounts, you can have multiple keys. Okay. If you have multiple addresses, of course you will have to have multiple keys, right? So Bitcoins are associated with keys, not users. So public key and private key will define you can send the Bitcoin or receive the Bitcoin. Okay. Every transaction is signed with creator's private key that we have already discussed. And if you lose your private key, there is nobody to call. You lose everything. Okay. And there have been a lot of cases where people have lost equivalent of millions of dollars. Now key size is 256. Okay. And okay, these keys are stored in the file or database called wallet in each machine. Okay. Now it means that private key is generated by picking a random number between 1 and 2 raised power 256, right? Because key size is 256, so randomly generate. Okay, and you can use your OSS random number generator for this purpose. Okay, okay, all right. So you can use the hash. I mean, if nothing else, no random number generator, then it can be using hash also, right? But it's advised to use a good random number generator. But so 256 bit key will look something like this, which is extremely difficult to remember. Okay, and these are derived, and public key is of course derived from private key using like elliptical multiplication or some other methods, right? Okay, all right. Now this may be very long. Okay, so some people try to reduce the size, right? It's left to you, right? Not necessary you should have 256 bit long public key, public and private key. If so long is good, but it can be reduced to 58 characters long using the method that's given here, right? Please go through it. Okay. So we sometimes we call addresses short form of public key, but in this class we will just restrict to 256 bit public and private key. Yeah, can you please mute your mic? So now all the bitcoins that have been generated so far are hidden in large number of private keys, and this is the maximum number of private keys that can happen, and this number is very, very large, very, very large, right? A small portion of that is actually being used. So practically impossible to overlap. It's impossible that two people have same. It's very, very low probability that two people will have the same key, right? Right. So basically population of world is 8 billion. Okay, let's the number of machines are same as number of people, then every person can have 2 raised power 224 addresses to themselves. Okay, there is an example which says that number of grains on sand is just 2 raised power 63. Okay, so how many such earths you will need to reach this number 2 raised power 256, right? Another example that we have gone, you go to not only Goa beach but any beach in India, pick up a sand, grain of sand, color it, drop it somewhere, and then ask your friend to pick up another grain of sand, and then probability would be very, very small that it's impossible, very, very negligible that the person will have same grain, right? Now anybody can participate in Bitcoin network. Only thing you need a public key and private key. That's fine. Same thing. Now the question is that, okay, just a minute. Okay, sorry. The question is that who generates this? Government makes money in general, right? Government makes the money, right? And based on the wealth of the country and so on, you must learn about how all these currencies come into play and what and all about it. But here, who in this digital world, there must be some way of creating money. Of course, there is a way of creating bitcoins, which we call it BTC, and that is the reward that person gets. Okay, doing some activity. Okay, we call the users who participate in all this activity are called miners, and these miners can create a block of transaction and add to the blockchain. Then that person will get some Bitcoin, or the one who will approve this block that is being added, the person, that miner also gets a Bitcoin, right? And these rewards have been reducing over time. Okay, so first 210,000 blocks, they got 50 Bitcoin. The next, these blocks, they will get 25 Bitcoin, then 12 point, then next 210 blocks get 12.5 Bitcoin, and so on and so forth, right? So now it means that number of generation of Bitcoins as time passes will reduce, and overall number of Bitcoins will remain, will not exceed the number. Okay, all right. So earlier it was much easy for miners to generate Bitcoin. In fact, many people generated Bitcoin using their laptops. Now you require more special purpose, computers and powerful computers to mine a Bitcoin. Any question on this one?
Sir,
Yeah.
sir, like you mentioned that for each transaction we'll generate a new public key and a private key to maintain anonymity. But sir, then how will the database keep track of how many bitcoins a person is owning? Because the identifier for any person was.
We'll come ask this question at the end, right? We'll come to that, right? Because there's no
Yeah, sir.
central server.
Yeah, sir.
Okay. Now you have some Bitcoins that everyone knows. Okay, you possibly you're a miner and you would have got it, or you would have bought it with that identity that there's a number of Bitcoins available that's known. Now you change your identity, you create new thing, right? Now then what you have to do is that when you change your identity, suppose you have 4 Bitcoins with identity 1, then you have to do a transaction between identity 1 and identity 2 and then transfer this to another identity. Okay, all right, so we'll come to that. So each block contains transaction and transfer rewards to mine. The basically the miner who is able to approve the block, will come to that later, get some incentive in terms of Bitcoin. And there are other miners who are not successful in creating a new block, but they are part of the system and they should have some incentive. All these miners will approve the block, that all transactions in the block are valid. Okay, so they will also get some Bitcoins. Now, if part of the Bitcoin, a Bitcoin is quite a big number. Okay, now when we are creating a currency, then there should not be double spending. Now you suppose you have a note of 100 rupees. Okay, you go to a shop and give this 100 rupees, right, and get something in return. You cannot spend, you cannot have, now once you have done this transaction, this note is with the shopkeeper, you cannot spend this twice, you cannot do this, right? Okay, now similarly you have money in your account, bank account, and you go to amazon.com and buy something. Now this money will, note or money will go away from you, right, because bank will keep track of you. Now the here in digital currency, which is peer to peer, it is very simple. If you don't design it well, it's very simple to duplicate the money, okay, and then spend it twice, right? So now that should be, that's not, that should not be allowed. So you, for example, okay, so there is some money with this guy Alice, okay, and then she can send the money to two people, right, Bob and maybe Mallory. Okay, now this should not be allowed. Okay, because money is anyway connected with private key and public key, so but she can sign the transaction. But how is it possible that other people will come to know that she is doing double spending? Now note that everything is peer to peer here. It means that now the whole public will should somehow find out that Alice is already spent the money and she is doing the second transaction. Okay, so this should not be allowed. Now, okay, how is it this possible? Right, so basically the transaction that Alice will be doing is of this form. User P1 transfers the coin, this coin, like the one which we have shown here, the coin here, with some identity with the coin, okay, to user P2. Okay, all right. All right, so now this transaction is known to everyone. Okay, in blockchain, right, because everyone can read the blockchain, and when she uses the same money for the second time, then people will come to know that she is using the money for the second time. Now the question, this raises another question, right, that she may have more money than you know, then for example she is sending $1 to Bob, she can have maybe $4, and then it's illegal to send another dollar or Bitcoin, sorry, here to somebody else, but same Bitcoin cannot be sent. Now she has just one Bitcoin, she cannot send it to two people, one Bitcoin. Okay, how will this come to know? Because when people will can find, should have ability to find out how much Bitcoins Alice has, looking at all the history right from beginning, and this history is available in blockchain right from beginning. When you open an account with an identity, okay, that how, and possibly you have got say one Bitcoin or two Bitcoins, and then you have been spending and changing your identity, it can be tracked back that you initially had two Bitcoins or four Bitcoins or whatever, right? So you can, so because everyone is watching it, so everyone can find out that you're spending more than what you have. Okay, and that will not be allowed. All right, if she uses the same Bitcoin, then people will come to know that you have already spent this Bitcoin. Now we are again not going to get into details, right? Whether what is how Bitcoins are actually will have some identity or whatever, right? We'll not get into it. Okay. No stealing, right? So if Alice has some Bitcoins, say for example 4 Bitcoin, then Trudy or Mallory cannot move this Bitcoin to somebody else. Okay, so stealing is not possible until unless Trudy comes to know about her public key and private key. Public key is anyway public and private key. If these two things are secret with Alice, then nobody should be able to steal the money. Okay, then fair money creation, because money should be created also, right? And in order to stop inflation, then after some time nobody should be able to create the money. So there is a way of way of creating money is by rewards, right? Rewards to miners. All right. So the key ideas is no stealing, no double spending, and minting should be legal. For minting, it is required that person should do the work and solve a puzzle. Many people can do the work, right? Of creating a block, collecting data and creating a very simple thing. But they should do something more than that to be eligible to attach the created block to blockchain, and that's called proof of work, which we'll study later. Now all this is decentralized. All right. Okay. Now next principle is basically blockchain, transaction and transaction table. A blockchain looks something like this. Okay. So we'll not get into actual structure of it. We'll look at only at the concepts, right? So property is authentication, signature, non-repudiation, there is a proof of ownership and integrity. So these are important things. Okay, and in order to do the transaction, authentication, all these techniques we know by now, right? Okay, available, like we are going to use public key, private key, then we are going a digital signature for non-repetition, etc. Right? Okay, and then in order to spend, one should have funds and no other transaction using the same fund, no double spending, right? Okay, so look at this diagram carefully, right? Okay, Alice generates public key and private key. Bob generates public key and private key. Now Alice, that is everyone knows about her public key, so she will send as a sender's address as her own public key. So Alice sends, or Alice public key or Alice machine with the public key sends 1 Bitcoin to Bob. This is Bob's public key number, this number. Okay, and then it attaches and also has a hash of the blocks where there are details of where she got the money. Okay, because Alice must provide some information that the money, this Bitcoin is earned, or this Bitcoin has come to her from somewhere, right? So she will also give hash links here. Okay, okay, so hash link to earlier transaction, and people can use that to find out whether she is actually earned the money earlier. Okay, and this all transaction is signed, this transaction is signed using Alice's secret key. Okay, and this transaction valid if the signature verifies. Okay, all right. So we can just go through it. It's same thing. She creates a transaction, sends 1 or more Bitcoin. Net tells this peer about the transaction. Okay, she sends it to the neighboring node, and then everyone comes to know about it in that network. And within 5 seconds, peers on almost every peer in the network has this transaction. Okay, this transaction is currently unconfirmed. Okay, now, and then as Alice also needs to provide links to previous transaction that will add up to at least the required amount. Now everybody, all the miners can look at this link and find out that the money that Alice is sending actually is there, or she has got it from somewhere. Okay, and they can validate this. Output, of course, is transaction is destination, it is the amount. Okay, and then of course as a part of transaction, the money that she has reduces, right? Okay, and now important thing is that every input must be completely spent. Okay, and any excess generated as another output to the owner of the transaction, right? So for example, Alice has 2 bitcoins, then these 2 bitcoins must be spent. She can't just spend. Okay, now how is it possible? While she wants to send only 1 bitcoin to Bob, in order to spend 2 bitcoins, she sends 1 bitcoin to Bob, 1 bitcoin BTC, and 1 bitcoin to Alice herself. Okay, get it? So all the money that, suppose you have Bitcoin account, all the bitcoins you have to spend in each transaction. Okay, of course part of that will be go to whatever merchant or whatever, and remaining will come back to you, but that's another transaction. Okay, all right. And then when someone receives it, then validate the signature using Alice's public key. Right here she has signed this transaction, so everyone can use public key to validate this. Okay, this proves that whoever created a signature has private key corresponding to public key. It means Alice actually signed by Alice, right? Okay, all right. So this will also ensure that there is no double spending, because now this transaction will go into, everyone can look at it, everyone can check it, and then can find out if she is double spending the money. Okay, because if this money has been used in any other transaction, people will come to know about it. So basically what are we doing? In a blockchain, we are emulating public trusted bulletin board in some sense, right? Okay, all right. So what are the block contents then? Now, all right, so a block is to be formed and it is to be attached to existing blocks in the blockchain. Okay, now this block, let's assume, is to be formed, right? But each miner will have a complete history of the blockchain. Okay, and you can also have, in fact, and not even being miner, you can have complete Bitcoin ledger or complete blockchain starting from the first block. Okay, and the current size is around 550 gigabyte. So transactions are grouped in a block, the number of transaction. Okay, approximately one block contains 2220 transaction, each transaction of 250 bytes, and block size is 1.25 MB, and one block is mined every 10 seconds, 10 minutes. So it's quite slow. Okay, so basically miners keep looking at the transactions, put it in the block, and try to attach that to a blockchain, and that happens every 10 minutes. Okay, any question? Okay, all right. So this is the block that is to be added to a blockchain, right? Fill all the transaction like this. Alice sends 1 Bitcoin to Bob, Alice sends 0.7 Bitcoin to Chris, and so on and so forth, right? This is between time t and time t plus 1. Okay, and you can see the complete blockchain. You go to this blockchain.com and you can see the complete blockchain. All right, So now it is, and this blockchain stores every transaction and checks user balances, because now everybody can check, every user's balances, right? How much money, how much bitcoins each user has. So there's, for example, at time t, Alice has 2 bitcoins and Bob has 5 bitcoins. Okay, after these transactions, because Alice sends 1.7 bitcoins to Bob. Okay, so she will have 0.3 bitcoin, while Bob sends 1.2 bitcoins to Dave. So after all this, receiving 1.7 minus 1.2, Bob will have 4.8 bitcoins. Is it correct? There must be, yeah, okay, this is not to Bob, this is to Chris. Okay, all right. So, right, so what are the properties required? Append only. Now, blockchains are being created, this is a chain, is a linked list, right? This is the initial first block. Okay, and they, all right. Now you can only append a block, new block to this, right? You cannot delete a block. You cannot delete any block, because everyone has a copy of this, and this is the rule. The people can see if somebody is trying to manipulate this, right? Now some transaction has have gone into it, right? For example, here some transaction has gone. You cannot reverse a transaction. Okay, all right. So reversal of transaction or changing, revising the existing block is not, it's not allowed, because everyone can see that. Okay, it's distributed, anybody can have a copy of this. Okay, and miners of course will have, only then they can check. It is live, it must remain live all the time. And okay, so everyone have same visibility of transactions, and it's on internet. Obviously internet is on all the time, so everyone will have live blockchain available. Okay, and it's open, anybody can participate. Any question up to this point? Who maintains the Bitcoin blockchain? Of course the miners. Miners have special this responsibility, because they want to do transaction and they want to be correct when approving a block, etc., or approving a transaction. Then of course they will have a copy of the blockchain. But anybody, you can also keep the copy, no one stops. Okay, so basically we are trying to change this ideal world with a centralized kind of bulletin board to distributed, completely peer to peer. Okay, all right. Now the question is that with that, there may be somebody here who's Mallory, who can cheat. But whole system will work if the majority are honest, because ultimately there will be voting for every transaction and every block. Okay, and if the majority wins, then everything is good. And but how can you say that majority are honest? Because these miners have no incentive to be dishonest, because they will be disqualified. Hello, some guys are not attentive, and then and they have not muted themselves. Okay, all right. So as long as majority are honest, hey, please mute yourself, otherwise just drop off the class. Okay, now the block creation. Who can create block? Now everyone is listening to transactions that are happening, right? The Alice is sending a Bitcoin to Bob. Bob may be sending it to Chris. Chris may be doing nothing, and then maybe there are other users who are doing, right? And all these transactions are being listened by everyone. You can also listen to that, right? Okay, all right. And especially the miners who have interest in earning Bitcoin. as an incentive. Okay, so they are all listening and they are all trying to create a new block. Okay, all right. So a new block is added every 10 minutes and size is less than 1 MB, and then new block gets added every, of course, at the end of the chain. And this was the first block, block 0, that was this called Genesis block, was created by Satoshi on 3rd January 2009, and you can see this block also. All right, now, okay, all right. So miners maintain chain of the blocks. Okay, this blockchain they maintain, but it is hard to extend it. Extending means that you'll have to add a new block, which is a valid block. Why it is hard? Because then only one of them will be able to add. If it is so simple, then everyone will try to add it, right? And there will be complexity because of that, right? So now let's look at the basic algorithm. It works as follows. Basic process. Alice wants to send a Bitcoin to Bob. Alice broadcast creates this kind of transaction that we have seen earlier. That's signed by Alice, and of course she adds to this hash link for previous transactions. Okay, and she doesn't know where the Bob is, right? She just sends this transaction to the neighboring node, and then through this net it reaches to almost everyone. Okay, it of course has a hash pointer to previous blocks showing Alice got paid earlier. Okay, okay, all right. So now this how it is. So Alice sends 1 Bitcoin to Bob, and this she will broadcast this or sends to neighbors, and it gets broadcasted. All miners will receive it, and then the miners will compete with each other to add the block. They will look at this transaction and also look at other transactions that are being broadcasted. Okay, and they will hope to add the next block, and they will never add a invalid transaction, because they will do that before adding that transaction to block. They will verify if it's okay, because whether it's a double spending or not, right? And miners are incentivized to do this, right? Because if they because they will get a Bitcoin if they do it correctly. Okay, so chain that has invalid transaction itself is not valid, so that copy of block that has invalid transaction will not be accepted, and the corresponding blockchain will not be valid. So the blockchain, because there are multiple copies of blockchain everywhere, the blockchain that has a valid transaction will become the main blockchain then. Okay, all right. So these miners will collect all these new transactions that have not gone into blockchain yet and create a block of certain number of transactions, and then, and this can be done easily, right? Now they will solve a quiz, a puzzle. Okay, and who solves the puzzle first will broadcast it. Okay, and other will verify this, whether this is whether the person has solved it correctly, and also verify all the transactions here, and then that winner, or we call it leader, will be allowed to add this block to blockchain. Okay, okay, so this quiz or this puzzle we call it proof of work. Okay, so it is computationally hard to extend the chain or add the block. Okay, once miner finds the block or solves the proof of work, then broadcast to everybody, and everyone listens to it and validate it. Okay, all right, and the one with the longest chain is valid one. Okay, all right. So this suppose this miner has able to solve the puzzle proof of work, and before that he has created the block, and will broadcast to everyone that I have extended the blockchain and here is the new block. Then now everyone will check whether this newly created block is valid or not, looking at the transactions and so on, right? And then they will do the voting. Okay, and the majority wins. If the majority agree there's a valid one, then that particular miner is allowed to add this to blockchain, and that blockchain becomes a valid blockchain then, and everyone will have a copy of that blockchain. Okay, it works well if all our users are honest, but this is not the case in practice, right? Some can be dishonest also, some may be lying. Maybe, for example, this may be lying. Okay, now we are assuming one vote from each, right? Okay, we'll see that this guy can create multiple VMs or whatever and can in fact do multiple votes. Okay, and this kind of attacks have been happening in the past, right? Okay, all right, but we'll not get into this. And in this way the new block is added to the blockchain. Okay, this is a new block. Who will get the money out of this? The one who has won this, who has solved the proof of uh, who has solved POW, proof of work, in the first place. Okay, and after that it has been validated by all. So the miner who has solved the first will get maximum number of bitcoins, and all other miners who have validated it will also get some bitcoins, small amount of bitcoin. So everyone is validated. This is another view, same thing, but I've taken from different source. So this is a blockchain. There are multiple transactions by multiple users. Okay, this is transactions signed by their private key. Okay, and then these are all available to miners, and then one guy will be able to solve it fast, solve POW fast. After validating all these transactions, will be able to create this, put this in blockchain, and as a result of that this guy will get the Bitcoin. Okay, and all other miners will also be getting something, and all these miners of course will verify this, whether this block is valid or not. Okay, and after some time there will be another set of transactions by once, next time slot, time period, then this maybe other guy can win it by solving POW and add this to blockchain. So in this way blockchain keeps extending, right? Then what is a proof of work? What is the reason for that? A proof of work means that every miner must spend some computation in order to be eligible for Bitcoin, right? But somebody can of course create multiple identities, right? Okay, if voting is done only by the number, each machine has one vote, then this kind of attacks are possible, right? Now what is done is that instead of this, okay, everyone must use computing power. And computing power for what? Computing power for solving POW, proof of work. Okay, all right. So now whether there are multiple identities, if they are still able to solve the problem fast, then they can win it. But that's not the case, because computational power is the same, or whatever. One who has a more powerful computer will have more, but by increasing the identities will not help here. Okay, all right. Now we'll spend some time on what is the proof of work. Is as we said, the miner who wins it is able to attach it and attach a block to the blockchain. So puzzle should be difficult to solve. For example, this hash function. This is hash function, or we usually use h of x is equal to y. Okay, so now if you give y, the puzzle is that find out the value of x. Okay, now we know it's a one-way function, right? So now you will have to do exhaustive, h function, then put all one value, second value of x, and so on, so on. So basically, there is no direct formula to get x, value of x, but exhaustively this the computation is to be done to find out value of x that matches with hash of that matches with y. This is one puzzle. Another puzzle which is very popular now, possibly I think this is the one which is being used. So basically, if given value of x, you'll have to find out s such that h of s of x. Okay, x is one string that's given as a challenge. Now you'll have to find out string s such that h of s appended with x, the whole hash of that starts with n zeros. So you do hash of s append with x, and the output is n number of 0, 0, 0, 0, 0, whatever n number, and then something, then that person will win it. So but doing this again requires a lot of computing, because there is no direct formula. You'll have to just put values one by one and check whether the answer is there, right? Okay, so proof of work. So basically you're earning Bitcoin, you'll have to make real effort, and it should be fair to everyone. Okay, and then you will use your machine cycles to generate it. It's not coming for free, right? Like, it's not because of gold, like, country has more gold is rich, right? But here the coins are minted not for free but using computing cycles. Of course now Chinese have earned a lot of Bitcoins using very powerful computers. Okay, all right. Okay, so now it is making it expensive to cast the vote, right? Because everyone has to solve proof of work. All right, so please go through it. It's just simple, right? Now of course this is the way POWs are used. Okay, same thing, you'll have to find out the value of this string or nonce such that it starts with a number of zeros. Please go through it. It's the same thing, right? So now please go through it. Same thing that we have discussed is I have given it here. Please go through it. To summarize, Bitcoin is currency that doesn't rely on central authority. It's peer-to-peer and is the most powerful, right? And is likely to remain in use. Okay, there many cryptocurrencies came and died, but this is the most powerful one and most maximally in use. It has gone acceptance, is becoming popular, is also being now recognized by many governments. Okay, it uses public key cryptography, it uses transactions, and users have to use a transaction using digital signature. There's a public ledger called blockchain. Anybody can have a blockchain, anybody can, if miner, then can attach it to the blockchain, block to blockchain. And then people who attach to blockchain has to first solve the POW, proof of work, and all the transaction is valid, which will be checked by other miners. Then block will be attached, and that particular miner will get money, and all other miners, because they are doing work, will also get some incentive. Okay, all right, and everything happens because of the consensus or voting of miners. Okay, all right, that's all. Any question?
Sir,
Voting from minors is only when they have correctly solved the proof of work.
Yes.
Okay.
Yes.
While sending some cryptocurrency, I am using only my private key, or do I also have to send my public key?
Yeah, good question. How will somebody know that it's come from you? Your identity to the outside world is only by your public key. Private key, nobody knows, right? It's a private. You are just signing it. So everyone should know your public key, right? Otherwise, they can't validate, right? See, you have done the signature, but how can somebody verify your digital signature? They need your public key, right? Isn't it?
Yes, sir.
I'm happy that you're asking this question. There are hundreds of other questions that will come to mind, because what we have covered in these 2 lectures is just crisp. We have taken out a lot of details, lot of details. Okay, just I wanted to tell you about the flow that I understood. Of course, I am not an expert. Okay.